would skip a step.
Proving the derivative of like secant theta.
Uh-huh.
Can I like multiply the top and bottom by like whatever? And then do I just show out my algebra? Like show
Well,
that I multiply both the top and bottom.
okay, let me do it real quick. Just cause I forget exactly where you do that. Secant x, we want to find the derivative of that. So if f of x is equal to secant x, that's equal to f prime of x, which is equal to secant x plus h minus secant x. Shoot, I don't know why my secant x all over h, right?
Yeah.
Okay, hold on a second. Okay, well, um, we can do, shoot, sorry, my mouse is bugging out for some reason. All right, there we go. So if we do, we can do secant x plus h, that's 1 over cosine x plus h minus 1 over cosine x all over h, right? And then that becomes cosine A cosine B plus sine A sine B 1 over all of that minus 1 over cosine x over h. Am I in the right direction? I haven't done this in a while.
Yeah, I think so.
Okay. I'm going to multiply by that on the top and bottom. And then, is there a way to like drag this? No, there isn't. Okay, well, cosine x, cosine h. So then that becomes 1 minus cosine h plus sine x. Uh, wait, shoot, sorry. That's completely wrong. It's cosine x minus uh cosine x cosine h plus sine x sine h over h times all of that. Is that what you were saying, the multiplying? Is that where you wanted to skip a step or something? Uh, well, how would you even skip it? You'd have to show it. You could show it the way I did, where I just put it on the outside in. I that's what you were referring to, right?
Yeah.
Okay. How would you go from here again? I'm just thinking about it. Can you plug in h yet? No, you can't. You have to cancel out the h. Where do you go from here?
You split it up and then start cross canceling stuff.
So I turn it into cosine x times 1 minus cosine h. Is that what you mean by splitting it up?
You basically just split the denominator for everything. Like split it.
Oh, okay. And then, okay, yeah. So you split the denominator, and then this cosine x, so you get cosine x over h times all of that, minus cosine x cosine h over h times all of that, plus sine x sine h over h times all of that. Am I doing it right? And then that becomes 1.
Yeah.
So then you get,
Cross cancel the
oh, what do I cross cancel?
subtract the two terms. The first two terms. They're the same terms.
Oh, right. Yeah. Okay. So then that goes to 0. that goes to 0, and then
Then you can plug in H for 0.
shoot. So that goes to 0, and then you can plug in H for 0, you said?
Yeah.
Yeah, okay, yeah, you can. And then it goes into, and then once you plug in H for 0 here, you probably get secant x tangent x. Okay, alright. I just wanted to refresh my memory on that. Alright, is there anything else you wanted to go over? Did he give you a theory pre-final?
Yeah. You get it real quick.
Alright. I can pull out my theory packet too, because we have basically the same thing. Or we don't have the same packet, but we have the same stuff. You have your packet on you?
Yeah.
Okay.
Also, what's limit? I just had what's limit notation?
Uh,
Wait,
wait, hold up. Say that again.
what's limit notation?
Oh, limit? Oh, that's just the limit definition. You know what I'm talking about? Let me.
That's what I thought. But
Could you give me the whole problem? It'll make
yeah,
more sense.
it's
Do you have the whole problem? Is it part of a bigger problem or?
yeah. Take a picture.
Oh, okay, yeah.
What are you doing here?
Okay. Oh, you know what's the definition of continuity? I think I talked about this like way early. Do you know what it is?
I do not.
It's the limit as x goes to a of f of x is equal to f of a. So what this implies is one, the point has to exist, right? F of a has to exist, which means that you can't have holes. That's why we say holes are discontinuities, right? And then it also implies that the limit from both sides has to approach f of a. It can't be like this, right? Because that's not continuity. So that's the limit. That's the definition of continuity. And you know what's interesting? The definition of differentiability is the exact same thing, just for f prime of x. Because if you think about it, right, if the derivative is not continuous, right, then that means the slope jumps immediately, like the absolute value, right? Oh, I don't know why I did that. Hold up. It jumps immediately, right? It goes from here to here, the slope. So your original function has a sharp point. That's why we say sharp points are not differentiable. That means the function isn't differentiable. Same with for differentiability, if your derivative has a hole in it, that means that you can't take the derivative of that point. But since it's not like this, right? That means it approaches the same thing from both sides. So what that means is that the point doesn't exist in the original function either. Those are good theory things to know. So does that make sense?
If the point doesn't exist, it doesn't have a limit, it doesn't exist on the actual graph.
If there's a hole in the derivative, there's a hole in the original function as well. At that point. That's the only reason there would be a hole, if you think about it, right? Because if it approaches the same thing from both sides, that means it's not a sharp point, right? Because a sharp point would be like this, where it doesn't approach the same thing from both sides, right? Versus here, where if there's a hole, but it approaches the same thing from both sides, the only possible explanation for that is that there's a hole on the original function as well. Does that make sense?
Wouldn't that be filled though? And the y prime graph is
so if y prime looks like this, right? Let me do something easier. If y prime looks like this, right, just flat, right, then y looks like this with a hole in the same spot. Because the reason for that is, so what was your question again? I was about to get to it, but I just forgot exactly.
My question was, wouldn't that point still be filled on a y prime because the limit still exists at that?
Yeah. I'm talking about if the y prime has a hole in it. What does y look like? If y has a hole in it, then actually it goes both ways. Because think about it. Look at this definition. F of a has to exist, right? Otherwise, you can't do anything, right? So if there's a hole in the function, then there's a hole in the derivative. And you can think about it also with the limit definition, right? F of x plus h minus f of x. You need that to exist, right?
Yeah.
Otherwise, it's not differentiable. So this is a good thing to know. This is probably, I think it showed up a decent amount on my theory test. So that's differentiability, and continuity is the same thing, just with f of x.
So continuity is basically when f of x is continuous, and then differentiability is when f prime of x is continuous.
Yeah. And yeah.
Sorry.
Yeah, so differentiability is continuity for your f prime. For your derivative.
So on a differentiable graph,
yeah.
The graph of y prime has to be smooth, right? It can't jump.
Wait, repeat that? Sorry.
On the y prime graph, if a function is differentiable, it can't be sharp, right?
If it's sharp on the y prime line, is that what you mean, like this?
Yeah.
Okay. So it doesn't really mean much for the actual original function, and the reason for that is because what this says, it tells us that the rate of change of the slope, right? So our y double prime, right, does not exist at that point. So it goes from here. Let me clean this up real quick. So if that's our y prime, our y double prime looks like that, and then there's a hole at a. Let me make that a, right? And then it goes down to here, right? But for our original function, that doesn't really mean much because, shoot, I kind of structured this pretty badly. Let me center these. so it's a lot. Oops. So it's a lot easier. So that's centered. Let me center this one too. Okay. So what it shows for our y prime line is it shows okay. So our slope starts at negative infinity, so it goes here, right? And then it goes, and then it comes down to negative infinity again. So it's not it looks like it looks like an x cubed, but it's not an x cubed. It's just a flipped x squared. But anyways, all it shows is that the rate of change of the slope, so the way the slope changes, is not smooth, which is really not noticeable in the final graph. It's kind of hard to tell. It would be like it goes up, right? And it looks like ignore all of these. If there was some sort of sharp point, it would look like it's going up, 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 and then immediately it breaks and starts going down like that. Because it's still differentiable, right? Because the point still exists in the derivative, right? But like it's just really hard to notice. So yeah, sharp points on y in the derivative don't really matter that much. That was a bit long-winded, but
on the actual graph, like an actual y graph,
uh-huh.
it's not differentiable, right?
Yeah, because the let me show you. So like an absolute value, right? What's so the absolute value looks like this, right? The slope, sorry, the slope from the slope here is, let's say, -1, and then the slope here is 1, right? But that means the limit as you approach this point, the derivative, is not the same thing. So what it looks like in the derivative, if this is y prime looks like this, and then that. So it's not differentiable at that point. And you can think about this with the limit definition, f of x plus h minus f of x over h. It's the limit at both sides as x goes to h from both sides. But if as x goes to h from this side, it's -1, but as x goes to h from this side over here, it's +1. So that's why it's not differentiable, because the limit doesn't exist. Does that make sense? It was a bit long-winded, but
Yeah.
okay.
So basically, if the slopes like don't gradually change into one another,
Yeah, then it's not differentiable. Yeah.
Okay.
If right now that the y prime graph that you made with the straight lines, if that was the y instead of the y prime, would the absolute value looking function be like the antiderivative of y?
Okay. Hold up. So 1 second. First of all, this should be over here, I just realized. And then second of all, you're saying if this was y, if this was y prime, what would y look like? Is that what you're saying?
No, if what before was y prime, the graph that you just adjusted.
So is this y? Is that what you're saying? If this is y?
This was y.
Okay, okay.
What would the absolute value be the graph like?
If that was y, then the integral of y should be at absolute value, I think. Let me see. So if that's y, then would it be that plus c, obviously, but let's say no plus c for now. Yeah, and the reason for that is, if you think about it, actually, let me think about this. Yeah, the reason sorry, the reason for that is so like I talked about last time, this integral also means area under the curve. So you can think about it like, okay, if we start here and we start adding area, it goes greater, right? So that corresponds to this, right? But then I'm gonna undo that. But then as soon as, come on, but then once if you add up this area, that corresponds to this rise and change, right? And then, but then if you go from here to here, right, and you're adding up the area, actually that means nothing. But anyways, yeah, does that make sense? Sorry, that was also a bit weird, but yeah. Okay. Any other questions? I have some stuff in my theory pre-final. We have basically a really similar one, so I can go over a few of those.
82.
Yeah, 82.
What is those?
Come on, 82. Sketch. Okay,
Oh, no, sorry, 84.
84. Oh, sketch a function such that. Okay, well, let me erase everything real quick. Come on. Okay, so okay, sketch a function such that f of 2 is equal to 4, f of 4 is equal to 2, f does not satisfy MVT, so no MVT on 2, 4. Okay, this is a lot of stuff. Hold up. F prime of x is greater than 0, and f double prime of x is less than 0, for x is greater than 4, limit as x approaches 0 positive of f of x is equal to 1. 1. Limit as x approaches 0 negative of f of x is equal to negative 1. Okay. Let me draw it neater. That's not big enough. Let me, there we go. Okay. So, from 2 to 4, actually, I should redraw this to make it more space over there. Okay. Let's say 2 is over here, and 4 is over here. F of 2 is 4, so it's up here. F of 4 is 2, so it's like over here. And there's no MBT. What's the definition of MBT? It's
basically the average of the 2 points exist, like a derivative of some point in between will equal the average.
Yeah, but the constraints are if f is continuous along
Yeah, it has
a.
to be continuous and differential.
Well, okay. Also, this is interesting. I was thinking about this the other day. So, actually, I'll come back to that. I'll come back to that right after I get done with this. But this is really important. This was something I was thinking about yesterday, and it's really cool. But let me just finish this real quick. If f is continuous along AB, and
If it has to satisfy both for MPT, meaning that it cannot satisfy either one, right? Or both.
Wait,
It
repeat
could
that?
Either be so like if MVT here has to be continuous and differentiable. So when we're sketching the graph, it can either be continuous, but it can. So like let's say.
Yeah, it just needs to be false for one of these or both. But
yeah.
I'll get back to that. Just notice how one of these is closed bracket and the other is open bracket. I'll talk about that soon.
Yeah,
That's
yeah.
really cool. But so f of 2 is 4, f of 4 is 2, no MVT. So that means it's not continuous along. So if x is greater than 4, let me skip this for 1 second. If x is greater than 4, f prime of x is greater than 0. So our slope is positive, but it's decreasing. But the slope's rate of change is decreasing. So it looks like that, right? It's a little bit extreme. I'll do like that. And then
How do you know if the slope is decreasing?
That's f double prime.
The double prime, which means the concavity is.
Double prime is the rate of change of the rate of change, or the rate of change of the slope. So if this is less than 0, that means the slope is decreasing, right? It's over here, then it decreases, then it decreases, then it decreases.
Oh.
but it's still greater than 0. So that means it's approaching flat. It's approaching 0, but it doesn't go down. So it's asymptotic.
That's why we have like concavity.
Yeah, that's what people call it concavity as well. And then, so that's x is greater than 4. The limit as x approaches 0 positive of f of x. So 0 from the right side is 1. So that's down here, right? From the positive, so over here, right? And then it's negative 1 for 0 negative, so over here, right? I'll call that 1, negative 1, 4, 2. And then, okay, so now all we have to do is know MVT on 2, 4. So we could probably just connect this, right? That's, I could, let's,
It's gonna literally just be like a line.
yeah, it could be a line. Wait, can it be a line? Because if it's a line, then it's not differential. If we made this a line, then it would not be differentiable at 4. Does that matter? No, it doesn't. So we can make that a line, yeah. And then we just need no MVT, so I could just go, and that should work. Does anyone see anything wrong with that? Because I don't know, it looks decent to me.
Wait, so MVT doesn't work here because the graph is between 2 and 4 is not differentiable.
Yes, because if it's not differentiable, think about it, right? That one point that's equal to the average slope, right, could just not exist, right? And that's continuous, but it could also be like, okay, it's about to approach that point. Let's say this is the point, right? A, this is the golden point that's equal to both of those, and then it could just go straight like that. Oops, I don't know what.
Wait, couldn't there be like a space between 2 and 4 or something? Then it would not be continuous.
It doesn't need to be both. If it makes one of these false, then it's fine.
Right, but like, would it also be like viable to have like nothing in between 2 and 4? Is that also correct?
Let me see how the question is worded. I guess nothing in between 2 and 4. Yeah,
It wouldn't
and
be continuous, right?
yeah, and the reason it is, if you look at 84, it says f prime of x is greater than 0 and all that for x is greater than 4. If it was greater than or equal to, then you would need to have points in between, because then there needs to be a limit on both sides of 4, right? But since it's just greater than, I guess it feels like a poorly worded question, but I guess you could just have nothing there as well.
Okay.
Does that make sense? Is there any questions about that? Okay.
Another question.
Yeah.
Is an absolute maximum or absolute minimum? Isn't it also considered a relative maximum or relative minimum?
Not necessarily, because if you think about it, let me do this. Actually, yes, it is. Ignore that. Yeah, it is. But only if it's not an endpoint. Actually, that was what I was thinking. If it's an sorry, if it's an endpoint. So let's say he just gives you a range, right? He doesn't give you a whole function, just a range like this or something, right? Ignore that it's not perfectly centered at 2 and 4. It doesn't matter. But let's say it's a range like this. Do you agree that that's the absolute maximum, right? Do you agree that?
Yeah.
But the relative maximum states the definition of relative maximum is that it's greater than its neighbors. But to have neighbors, you need to have it on both sides. But this doesn't have anything on this side. There's nothing on this side. So it's not a relative maximum. Does that make sense?
Yeah.
And so similarly, this is an absolute minimum, but not a relative minimum. Now, if he gave you a whole function, right, and he just told you to look at this range, then those would be absolute, would those be relative? Actually, if he gave you a range, would it be relative still? Like if he gave you the whole function even outside, but just told you to look within this range, would those still be? That's the thing I'm thinking about.
But for what the endpoint? For
Like if he gave you a whole function and he said just look between 1 and 5, right? And then he asked you if this was a relative maximum. Technically, it has neighbors, but they're outside the range.
I guess it's still not considered because I think if they're in the range, it's just cut off.
Yeah, I would say those aren't relative maximums, just to be safe. But taking the context, like I might be wrong first of all, and also, depending on how the question is worded, it might be actually those might actually be relative. It depends on how the question is worded, so I'd be careful about that.
I mean, they would be absolute.
They would still be absolute. Yeah, I'm talking about relative. If he let's say in the
Yeah.
question he says like consider outside values as well or something like that, right? Then you would say those are relative. But ignore all that. He probably won't do that. That's because that's like semantics. That's less theory and that's more semantics. But okay.
I have
Do you remember?
But yeah, Derek, do you want to go?
So for points of inflection,
Uh-huh.
if the y prime line like is always like double positive, like when you go through that critical number, if it's positive or negative on both sides, is it always a point of inflection or only sometimes?
Okay. So are you saying if it's a y prime line, right, and you have some point here, A, and it goes from positive to negative, is that what you're saying?
Or it goes from positive to positive.
Yeah,
It's A
positive.
to negative.
Yeah, if it goes to positive, then yeah, it is uh a point of inflection.
Is it always a point of inflection?
Yeah. Yes. Because to have to go to 0, the reason for it is you had some positive value here, right? And at here it's 0, right? So to go from this positive to 0, you had to be decreasing. F double prime had to be negative here, right? But then to go from 0 back to a positive, it had to be positive here, right? You know what I'm saying? So it did go from negative to positive. Otherwise, this situation is not possible, you know. So okay.
I mean, about how many? Do you remember about like how many?
Not really. It was a Friday period for us. I don't know if it's a Friday period for you guys.
It is.
Okay. I don't remember. I think we had enough time. It wasn't like, especially because a lot of the questions you don't do like hella work. Like it took me, like it's more about figuring out what you're supposed to do than like actually doing it. Because it takes like maybe 30 seconds to actually do like the math. Because it's like, it's not that bad. But it's actually figuring stuff out. So actually, let me get back to this real quick. So, what's the limit definition of continuity?
F of x. The limit f of x.
So the limit as x approaches a of f of x has to be equal to f of a, right? But if it's a limit, these endpoints, shouldn't these be closed brackets? Because it's on the same principle, because the endpoints don't have a limit on both sides. Those should be open brackets, right? Those should be not. They should be this, right? Not this.
Wait, what are we talking about?
So in the MVT definition, it says f has to be continuous along the closed bracket of a comma b, the closed ones, right? So that includes a and b. That's the definition. But something I always found weird was if the limit for continuity, if the definition of continuity is a limit, then shouldn't it be like differentiable where it's open brackets, right?
Yeah.
Yeah.
Does that make sense? My question there, like why I was confused.
Yeah.
Okay, so the reason for it
is that the definition of continuity? Because I thought continuity is that like every x has at least one y, or sorry, every x has exactly.
No, that is shoot, I forgot what it's called. I don't think it's called 1 for 1. I remember that was like the casual way of saying it. Oh, that's saying if the function if it is a function.
or not.
That's basically saying if it is a function, not if it's continuous, but if it's a function. Because this isn't a function, right? Because it doesn't, because that's two
Yeah.
y's. So that's what you're talking about, is whether it's even a function or not.
Wait, so what is continuity?
Continuity is that it's this. It's that basically the way a lot of teachers say it is no holes and then no jumps like that. That's
Smooth, basically.
well, smooth
But
implies smooth. Yeah, smooth implies it's differentiable.
wait.
This is continuous.
Never mind. Not smooth, but yeah.
I guess the way you'd say it is that instead of saying for every x there's one y, you would just say for every x there is a y, and then that the limit exists for every single point. So this is this is continuous because the limit applies. This is not continuous. Neither is this because the limit
Like,
doesn't
for
apply.
example, y equals ln x is not a continuous because x cannot equal negative number.
I think it is continuous. I think the caveat here is within the domain. I should include that. Yeah. Within the like yeah. I can't really find a better way to say it, but like within the range. Let me search this up actually real quick just to make sure I'm not telling you guys something that's false. Hold up. Let me search it up. Okay, it's not continuous, but it depends on the wording. So if they ask if is ln x continuous from 1 to shoot from 0 to infinity, you would say yes, that's true. But is ln x continuous? That's wrong. That's not wrong. It's not globally continuous, just along that domain. So actually, Derek, you're right. It is not continuous technically. Yeah. Does that make sense?
Yeah.
And then okay, so let's go back to this where I said, look, now when I'm talking about continuity, I'm using closed brackets. So why am I using open brackets here? The reason for that is if I write out the full definition, right? MVT's full definition. This also goes for roles because roles is just MVT but more specific, right? But the definition for MVT is let me write it out fully. If f is continuous along a b and differentiable along a b with open brackets, what's there exists? What's the symbol again? Shoot, is it this? No, that's not it. Do you guys not remember the symbol?
Wait, is this supposed to be MBT?
Yeah, MVT. I'm trying to write it out right now. Is it this?
If f of x, f is continuous. Along it, and
Yeah,
Yeah,
that's right.
there
The-
it is.
There exists a point C element A B. It can't be endpoints. Such that I think it's this such that
such that f of a minus f of b.
f of c is equal to f prime of c is equal to f of a minus f of b over a minus b. Now here's the key. Do you see that f of a and f of b have to exist? That's why we use closed brackets, because they need to exist as well, right?
What? So why do you use open brackets for like when you say like C is in between A and B?
Because it's just the reasoning is because f prime of c needs to exist, but it's differential along the closed bracket or the open brackets here, right? So the endpoints aren't differentiable, but f prime of c has to exist. Does that make sense?
Wait, so when you're saying C is between like A, B, use open brackets, right?
Yes, and the reason for it, does that make sense? What my reason for it is?
Wait, can you say it again? Sorry.
So the reason for this using open brackets is because
It
look
can't
over
be-
here, f prime of c has to exist, right?
Yeah.
So, but it's not differentiable at a and b, so those can't be part of
That's
c.
points.
Those can't be c. Endpoints aren't differentiable.
So because C is in
That's
between
what-
A and B.
Basically, if you had closed brackets, right, it would mean that
Yeah.
it would include A and B. But since it's an interval, that would mean that A and B would then be endpoints. But you're trying to say that f has to be differentiable in between A and B. But if you had closed brackets, that means A and B could be endpoints, and C is not differentiable on endpoints.
Oh, okay.
So yeah, the reason it's open here is because it needs to be different. C needs to be differentiable, and it's not differentiable at the endpoints. The reason it's closed here is because f of a and f of b have to exist because of this
Yeah.
part of the thing. So we need to just make sure they exist by putting closed up here.
Wait, so for IVT, you'd say she was in between the closed brackets A and B, right?
Well, IVT is different, I
Does that mean-
think, right?
That would be differentiable.
If f is sorry, if f is continuous along, I think it's open brackets, a, b, I can't remember exactly right now. Let me write it out and make sure it's open brackets. If f is continuous along a and b for all
closed.
c of an element a, b, there exists there exists m such that f of m or not there exists m element of f of a, f of b, such that f of c is equal to m. Is that the ignore the brackets? I'll get back to those, but is that the basic like thing? Or am I okay, cool. So if f is continuous, so do we need the endpoints? Yes, we do, because those are over here, so these need to be closed. But then now the question is, can this do we care about endpoints for C?
Wait. Why does A and B have to be in closed brackets?
Because we say M has to be an element. It needs to be in between f of a and f of b. But if one of these doesn't exist, then that interval, like, we don't know what that interval is, right? You can't have an interval with a number that doesn't exist.
Wait, so how can you have C in the interval of open bracket A and B?
Because this is different than continuity, right? We just the reason these are open brackets is because it's because honestly, okay, so the reason these are open brackets is because the whole point of this IVT is to show that we only care about the numbers. We only care about the numbers in between, right? So we don't want C to be the endpoint because that's not the point of IVT, right? The point of IVT is all the numbers in between. So that's why you could just as easily do closed brackets here, but then you need closed brackets here, right? But then you're just saying, okay, if C is A, then f of A has to exist. But we already know it exists. So it's just kind of useless. That's why we don't put closed brackets there. Does that make sense?
Wait, so you don't put closed brackets when you say like M is between f of A and f of B because you know M exists.
Because we know f of A and f of B already exist by putting closed brackets out by putting closed brackets over here. We know that f of A and f of B exist and A and B exist, right? So what's the point of checking for C at those endpoints? We already know those exist. Does that make sense?
Wait, can you say that again?
So since we put closed brackets here, A and B have to exist, right?
Yeah.
So f of A and f of B have to exist, right?
Yeah.
So what's the point of saying, okay, let's make C equal to A and check if f of a exists. We already did by putting close brackets over here. Does that make sense?
Yeah.
So that's why we put these open brackets, just because there's no point in having them being closed. It wouldn't necessarily be wrong to put them closed, but it wouldn't be IVT anymore, because that's not how the dude who made IVT did it, and no one cares about the endpoints, because we already said they're defined by putting close brackets over here. Does that make sense? I'm trying not to say it's because the dude who made it said so, but and it isn't. It's because we already made sure they exist by putting close brackets here. But the reason we don't, you can put close brackets here. It's just not IVT anymore. It's a new thing you made that's basically the same as IVT, but not actually IVT. Does that make sense? It's not wrong to put those there, closed here.
Yeah. And
Just-
it's the same thing for when you say like C is in between A and B, you use open brackets.
Yeah,
'Cause you already know A and B exist.
yeah, by putting close brackets here.
Okay, gotcha. Thank you.
Okay, so that should be IVT, MVT, and then Rolle's theorem, you guys know, is basically just MVT. It's just like a special case. So I don't need to write that out. Okay, what's left? Do you guys have any problems?
So when you're taking the antiderivative and you get like log or ln, do you always use like absolute value?
That's a good question. Let me erase everything real quick. I think it depends on what your domain of the original function is, and that's why it's important when you're taking the integral to just keep a mental check or write it off to the side what the domain of the original function was. So 1 over x, right? Can you plug in negative numbers into this?
Yeah.
Okay, hold up 1 second. I'm gonna go AFK for like 2 seconds, I swear. All right, I'm back. Can you hear me? Okay, so can you plug in negative numbers into this? Into 1 over x? Yes, right? The only thing you can't plug in is 0, right? So let's say we have ln x, just no absolute value for now. Can you plug in negative numbers into here? So how can it be that the derivative exists at a point but the original function doesn't? So that's why we put the absolute value. And you still can't plug in 0, so it's a perfect match between the domains. So, but then there's other times, let's say we do 1 over x. I can't think of a function right now. There has to be a function, but I just can't think of one right now that only allows you to plug in positive x. So just pretend I say 1 over x dx. When x is greater than 0. Just pretend there's some function that's like this. Then you don't need to put the brackets, right? Or you don't need to put the absolute value, because now the domains match without them, right?
Wait, so the domain of the derivative has to be the same as the original.
Same or smaller, because you can have functions that aren't differentiable at some points. So same or smaller, but it can't be bigger.
Okay.
Okay, so that's I can't think. I swear I can't think of a function. Secant x? No, secant x can be negative. Yeah, so most of the time you're safe with putting absolute values, but like, I would just check. I would just make sure the domains match. That's an easy way to make sure. But if you're in doubt, I would just put the absolute value anyway. I don't think he would be mad at you for doing this.
But why wouldn't you put the absolute value of like the initial question? Take the integer. Should it be 1 over like the absolute value of x?
For why don't I put absolute value here?
Yeah.
If I do, it doesn't. If I put it here, then then the antiderivative is actually something completely different. Because if you look at it, right, ln of absolute value of x. Actually, is it different? Shoot. That's what that looks like, right? Yeah. Wait. So that's ln absolute value. Shoot, that's not what I'm looking for. I'm looking for 1 over absolute value x. So this is 1 over x is this, right? Right? So 1 over absolute value x is this, and then this. This is flipped over, right? So that means that this is no longer, if you put absolute values here, this is not correct. You'd have to say it's, because now if you look, right, the slope here is positive when it's negative here, right? So if you put, hold up, wait, that's actually a good point. Wait. Oh shoot, you know why? Hold up, sorry, I'm all over the place today. We're talking about this being the original. Let's say ln absolute value x. Sorry, hold up. So I know what I'm trying to get at. I'm just like, I'm tweaking right now. Okay, so so that's 1 over x. So 1 over absolute value x. Or no, that's 1 over absolute value x. So the original function, right? So if 1 over x, we have ln x, right? So that looks like this, right? But you would need to, if you have an absolute value here, you need to split it up, right? Because all of a sudden, the slopes have become positive here, right? So you would need to say, for the antiderivative, so for the antiderivative of 1 over absolute value x dx, you'd have to say ln x if x is greater than 0, and then absolute value of ln x if x is less than 0. It's not that the absolute values transfer. That's not the reason there's an absolute value. You know what I'm saying? Does that make sense? I can explain it a little better if you have like a question about it.
That kind of confused me. Explain it again.
Okay. So does it make sense why we have an absolute, like, just for 1 over x dx, does it make sense why we have an absolute value?
Wait. Let me think.
It's so that the domains match, remember?
Oh yeah.
Okay, so let me erase everything so I can get a clean. Okay. So for 1 over absolute, so this is what 1 over, this is what 1 over x looks like, right? It looks like this, and then it looks like this, right? So it has negative slopes, right? Over here. But 1 over absolute value x has positive. Shoot. Okay, that's what I was messing up on. This is our derivative. 1 over x is our derivative, so that's not what I meant to do. We have negative values here, right? This is our derivative here, right? If we're taking the integral, that means these are our derivatives, right? This is negative here, right? With 1 over x. Does that make sense? But sorry, it's positive over here, right?
Yeah.
So if you had said, but then here ln absolute value x, that's the original function, right? It looks like this, right? You get negative values, but here you would need ln absolute value of x. You would need a function that works like ln x. It works like ln x on this side, but then on this side you would need it to be, I think you would need it to be flipped, right? You need it to be like that.
Yeah.
So it's not this. This would be a completely different thing. You'd have to split it up. I don't think there's a function that does this. You'd have to split it up and say, it's the antiderivative is ln x if x is greater than 0. Piecewise function, basically. Ln x if x is greater than 0. And then you'd have to say negative ln x. There it is. Negative ln x if x is less than 0. Because it would be flipped. Does that make sense?
Yeah, that makes sense.
So it's not if there's an absolute value, and you're taking the integral of something with absolute value. A lot of the times you can't express it as a single function, right? Think about absolute value of x. You'd have to do a piecewise function. So the reason we have absolute values here is just for domain matching, domain matching. That's what I'll call it.
So the domain of the original function has to match the domain of the derivative.
The derivative can only have the same or smaller domain than the original function. Because how can you have the derivative of something if the original function doesn't have a point there? You know what I'm saying? Does that make sense?
Yeah.
So when you take the integral of something, your answer should either have the same domain or bigger. It's the opposite if you take the integral of something. Does that make sense?
Yeah.
Okay. Any other questions? I can get out my theory packet because there were some good ones in there.
Can you just send it in the send pictures of it in the chat?
Yeah, I can do that. If you guys, I only want to do that because it's basically the same as your guys' theory packet. So if is there anything that you guys needed? Any other questions?
I was just kind of confused about like the format. Like, are there gonna be like derivations from like previous years? Like,
Not yes, actually there's one. Okay, so I had an 89. I got an 89 on first semester's final, right? And the main thing I missed was a 200-point derivation. That was literally like 5%, right? 200-point derivation on squeeze theorem. That's the one thing he likes to put. I'd be willing to bet money it's on yours too, because he likes that one.
and is it predominantly like?
And then there's a few derivations. I think at least 2, and then it's just theory problems like the one you have in your packet. Like 84 would be an example of like the theory problems you get. 84 in the one Derek just sent.
Wait, so the theory goes over derivations and like problems like 84.
Yeah, at least it did for us. I don't know. It was that way for us. So, do you guys have any questions on derivations? Like,
84, I got like a really stupid graph. Right?
do you want to send it? We can check.
Yeah.
Do you guys have any derivations that you guys want to do?
Now, can you derive the standard formula for the derivatives of an inverse function?
So, okay. Inverse. dy dx of an inverse. Okay, let me write that down. Okay. Well, let's say that g of x is equal to the inverse of f of x, right? This is actually one way to do it, and it's pretty easy, right? So that means f of g of x is equal to x. Do you agree?
Yeah.
So if you take the derivative with respect to x, you have to remember your chain rule, f prime of g of x times g prime of x is equal to 1. So f prime of g of x is equal to 1 over g prime of x. Does that make sense? Does anyone have a question? Oh, okay, wait. Ask your question first.
Take the derivatives of both sides.
Yeah, with respect to x. Let me put. I took derivative of both sides with respect to x. This is an easy one. I think there's one that you do with fractions too. I can show you that one too if you want. That's probably the one he showed you, I'm assuming. Before I show the fractions one, I just want to. Does anyone know? Can anyone explain why there's a g of x in there in terms of like how that works when you're actually doing it?
Wait, what do you mean?
Because the reason that there's a g of x here, all I'm trying to say is when you have a function like f of x, right? And there's a point xy, right? So f of x, if you have a point xy, g of x will have the point yx, right? So if you want to find g prime of x, right? If you want to, or not g prime. Shoot, is it g prime? Yeah. If you want to find g prime of x, right? That would actually be plugging it into the y, right? So when you do, shoot, I feel like I messed something up here. No, I didn't. So g prime of x, that would actually be plugging into the y of the non-inverse, right? So you would need to check what x. Shoot, I feel like I did something. Is this right? I feel like there's something wrong with that because I remember it's like, I don't know.
But isn't g prime of x the same thing as taking like f of x except in respect to y instead of in respect to x?
Let me think about that. No, because it also turns negative sometimes too, right? If it might sound weird, but let's say this is f of x, right? And we have the inverse. The inverse will, instead of xy, it will be, this will become x, and then this will become y, and then it'll still be, it is, but you need to turn your function in terms of y, right? Does that make sense? So if y is equal to x squared, right, and you took the derivative with respect to y, you would get 1 is equal to x squared. Shoot, I feel like I'm doing something wrong here again.
But
Took the
use power rule, so 2x times dx over dy.
yeah, that was what. Okay, so 1 is equal to 2x times dx dy, and then you would need to, it would be 1 over 2x is equal to dx dy, and then you would get dy is equal to 2x dx, right? Oh shoot, I'm going back to, and let's say just to make sure, let's do y prime if, let me, shoot, this is all messed up, 1 second. So y is equal to, let's say also say f of x is equal to x squared, and we want to find the inverse at 3 or something, right? How would we do this normally? We would say if x squared, if you plug in something, you get 3, right? In our inverse, you would get 3. You would plug in 3. So that's what we need to find. F inverse, so d dx. So 3. So then what can you plug into x squared to get 3? 3 is equal to x squared. You would plug in root 3. So that's root 3 out here. So root 3 comma 3. And so you would do 1 over f prime of root 3. F prime of x is 2x. So 1 over 2 root 3. Yeah, it is actually, you're right. It would just be the derivative with respect to y. Right, because if you plug in, you also get 1 over 2 root 3. Those are the same, Derek, if you're, so yeah, you're right about that. The yeah, that should be. I'm just trying to think of anything because other he should have just taught it to us like that if that's how it works. I don't know. Yeah, I guess that's true. You need to find. I think the principle he was trying to show you is you don't plug in 3, right? Does that make sense? You don't plug in 3. You have to find
Yeah.
what. I think that's why he taught it to you this way so that you get that instead of because I bet if he taught it to people this way, a lot of people would just like plug in 3 instead of actually
But
doing
you
it.
plug in 9 there, right? Because 9 is the y value that x equals 3.
Yeah.
Wait, do I plug in 9? Shoot, I probably did
Yeah,
something.
you did.
You did.
Wait, so you plug in root 3, right? Not 9. Am I messing up?
You want to find p prime of 9.
Yeah.
So if g of x is equal to f inverse,
Because
find g prime of 3. Well, so if you plug in some number to get 3 in f of x, if this is f of x, right? What number can we plug in to get 3?
Wait, isn't 3 your x value? The number you're plugging in?
3 is the x value of our g of x, right? Because it's g prime of 3. So it's 3 is equal to f inverse of x. Or g, or not g, shoot, sorry. 3 is not the thing we plug into f of x. That's the main thing. That's probably g is g is the thing you plug into the inverse, right?
Yeah.
So but the inverse is x and y switch. So that would be the y value of your f of x. So 3 is equal to x squared. Does that make sense?
Yeah, so 3 is the y value of your f of x.
Because it's the x value of your inverse, right?
Yeah.
Yeah. Okay. Yeah.
Say, could you check like the picture I sent?
Yeah.
The homework help one. It's hello, I just.
Yeah. Yeah, that should. Wait. Hold up. Continuous. MVT is if it's continuous along A, B, and differentiable. Shoot, I have to look at 84 again. Is it 84? Was that the question?
Yeah.
F of 2 is equal to 4. Is that true? Yeah. F of is that open circle at 2, 4?
So
That can be a closed circle because since you have an open circle already,
yeah.
you can make that a closed circle, and it would be correct. I think. Let me check. And then is it concave down past? Yes, it is. MVT on 2, 4 for F. Yeah, that's right. If you make that a closed circle, that one.
Yeah.
Okay. And then okay. What else did you guys want? Is there any other derivations? Does this make sense? The inverse one? I don't know. I can't really explain. I can explain it well. I just can't figure out how to right now. But does it make sense? Does anyone have any questions on that? Okay. Sorry. Okay, what else do you guys have? Any derivations? Because he could put any of those derivations on there, on the theory. So if there's one you're unsure about, did he teach you the one to prove that? I showed it on here last time, but did he actually teach you the one that to prove that integral is equal to area? Did he show you that one?
No, he hasn't taught.
Okay. Yeah, he'll probably show that next semester, so that's fine. You don't have to worry about that. Do you have to do the Pythagorean theorem one?
He hasn't shown that one either.
Oh, okay. Okay. So is it just the trig, like the proving all the derivatives of the trig functions and then the power rule, and then product and quotient, and then ln,
Inverse.
and then inverse. Okay. How do you do? I showed inverse this way. Is that the way he showed you? Because he showed us one with fractions using the chain rule. I can show that one too. He'd probably appreciate that one more.
No, this is how you showed it.
Okay, so he switched it because everyone was messing up on the chain rule one. So, okay, cool. I still wanna let me make sure the one with chain rule works. It might let me see if I can do it. So if the way you do it with chain rule is, let's say g of x is equal to f inverse of x, and we want to find dg dx, right? Well, it's df dx times dg df is equal to dg dx. So then, dg dx, we want to find dg dx. Shoot, even I forgot how to do this. I'm gonna be real. dg df so then shoot, yeah, I forgot how to do this. I'll figure it out later.
You put so instead of doing like f of g of x, it's g of f of x. So you take the derivative of both sides with respect to y when you set equal to x.
Wait,
Oh,
repeat
yeah, I
that.
think he might have shown this one.
What were you saying, Derek?
So you put you know how you did like f of negative 1x?
Yeah.
You did it on the other way, so it's f of negative f of x. So you put the you placed the x with f of x.
Oh, okay. So f of g of x.
F of x.
Is that what you're saying?
Yeah. It's no, the other way around. So it'd be g with f of x on the x.
Oh, okay. Yeah, no, I got it now. Yeah. G of f of x. So instead of taking, yeah. So we plug in f of x into each of our x's. That's what we're doing here. Is equal to x, and then dg df times df dx is equal to 1. So it's 1 over df dx.
Yeah, this is the way he taught us.
Yeah. This one, and it's df down here because of that inverse, the x and y switching. It's df here instead of dx. It's the same reason why it's f of g of x is equal to 1 over, because of the switching. Because if you plug in 3, you need to find g of 3, which will give you the y value, and then that'll become the x value, right? So but that's the reason that it's not just straight. Never mind. I think you guys get it. Okay. What else? There should be. I feel like there's. You guys know how to do squeeze theorem? I bet that's gonna be on the test. I bet money it's gonna be on there.
Wait, does you care if you set the radius equal to 1, or do you have to actually set the radius equal to r?
R. Just cause it's more general.
Okay.
So you're proving it's for all r and not just r equals 1. Though honestly, it doesn't matter because you're using trig functions anyways. But just in case, do it. Oh, and do you guys know? Okay, so this one's kind of funny. So for quotient rule, he does accept this. So if he asks you to prove the product and quotient rule on the same test, which he did for us, instead of doing like the whole thing for quotient rule, you can just do, since you already proved that f of x, g of x, right? Since you already proved that that's equal to f prime of g, or not, sorry, f prime of x, g of x times, what am I even trying to do right now? Hold up. I remember there was something we did it with. Yeah. Okay, so it's this. So since you proved this in the question above, this is like sorry. So since we proved this in the question above, he actually accepted us for proving the quotient rule. Just use a chain rule. So we would say it's f of x over g of x is equal to f of x times g of x to the negative 1 power. And so we plugged it into here and just did the chain rule. Does that make sense what I'm trying to show? You could do that too if he does that on your test and he accepts it and it's a lot less time. Since it's a Friday period, you might want to do that. But only if you prove this above, which we did which we had to do for one of our questions. Make sense?
Wait, what is the last step? F of x, remember g of x equals f of x times d of x to the negative.
Yeah, and then
you do chain rule.
Yeah, and then just do the product rule on that. So f prime of x times the derivative of this, which is times negative g of x to the negative 1 power, negative 2 power, times g prime of x. Shoot, am I doing this right? Oh shoot, no, I'm not doing this right. Hold up. Sorry, my brain's buzzed out today. So f prime of x times g of x plus negative g of x over negative g prime of x over g of x squared times f of x, right? And then you multiply the top and bottom by g of x squared, right? And you get shoot, I feel like I'm doing something wrong here. Oh, this is to the negative 1. That's what I did wrong. And so then you get f prime of x, g of x minus g prime of x, f of x, all over. You get the quotient rule. It was just a shortcut. He allowed it on the test. He didn't mark us off for that. Because we did this in a question above. Just because it's a Friday period, and I know you guys don't have like all the time in the world. So if you do the product rule in the question on the test, let's say question 1, and then question 2, he asks you to prove the quotient, you're allowed to do this with the chain rule. Okay. What else? Oh, do you have a question? I thought I heard someone speak up. Do you guys have any other questions? I don't really have much else. Oh, yeah. Did someone say they have a question? Sorry. I don't know if mine might speak buzz.
Fremont, speak up. Oh no, I don't have a question.
Oh, okay. Yeah, okay. That
Could you explain the limit definition?
yeah. 1 second. Only if you okay. Explain the limit definition.
Yeah.
Of a derivative.
Limit as h approaches 0.
Yeah, okay. So what is the derivative? What is the essentially a derivative? It's the slope of a point, right?
Yeah.
So another way we can think about it is if we have f of x, right? And we have 2 points. Let's call this x. And this is x plus h. We can basically say it's the slope of these 2 points as this point gets infinitely closer to that point, right? Those are basically the same thing. That's the whole basis of calculus, is those two are the same, right? And what's the slope of these 2 points? If we were to say the slope of these 2 points,
It'd be f of x plus h minus f of x divided by h.
Divided by x plus h minus x, which is h, right? The limit as h goes to 0 is equal to f prime of x, right? That's it. That's it. That's the whole thing.
So why so the limit is h approaches 0, right? It means that the slopes on both sides have to be like going towards it, or like
Yeah. That's why sharp points are not differentiable, because if you take the limit as you approach this way, it's a different value than if you go this way. Does that make sense?
yeah.
Okay.
BC kids also have to take the TV final, right?
Yeah, we get it on a Thursday. I guess, I don't know, maybe we have more stuff or something, but So, okay. That should be all. Any more
Oh, we
questions?
have a theory final for
Oh, yeah.
first semester and second semester.
Yeah,
Just
yeah,
one each.
yeah. Honestly, yeah, okay. It's not theory final is not that bad. If you know your derivations and then definitely do all the problems, make sure you like really understand all the problems on the theory pretest and then just calculus in general and you should be fine. Any more questions on anything? Okay. I mean, if there's no more
Like,
questions,
did you
oh,
ever go over the point of diminishing returns?
point of diminish. Yeah, you guys cover that?
That's just the point of inflection, right?
Could you give it in context? Do you have like a question to put it in context?
Yeah.
Because it depends on, I guess, yeah, it really does depend on the context what they're talking about diminishing returns. Because if they're talking about like a business and they're trying to sell a product with,
Yeah, that's what they're trying to
Yeah.
do.
then it's the point of inflection. And the reason for that is, right? Well, it's the point of inflection. Okay, this is actually important. Yeah, yeah. It's the point of inflection. So if we had a y prime line, right? And it goes positive, negative, positive. Which one is your answer, A or B?
A.
Yeah, it's A because you're on the up and up, right? You're getting more and more out of your product, right? And then all of a sudden you're not getting as much out of your product for the amount of money you're putting into it, right? So then even if it goes from negative to positive, this is still the better deal because this is just recovering from all the ineffectiveness that you had. You know what I'm saying? Make sense?
Yeah.
If you had
The question refers to like returns. Would that be like maximum return? Would that be the maximum profit at one point, or would it be the point of diminishing?
Did you send the question?
At the
Slope at the point.
Could you send the question if you is it sent?
yeah.
Okay. Yeah, yeah, cuz it depends on the for economics, it's diminishing returns means a slightly different thing than like I don't know, physics and whatnot, so it does depend. The maximum return. Okay, so the value of x at the point of diminishing returns, that's the point of inflection, positive to negative, not negative to positive. And then the maximum return is yeah, the highest point on the graph, right? So that might be a relative maximum, but it could also be the absolute maximum. It just depends on the question, right?
Wait, could you repeat that, please?
So let's say it's asking you for a given range for thousands of dollars, right? You'd also have to check the endpoints for absolute maximums, right? Because those would give you the maximum returns. But in general, right? So the function, the way this is set up, right? There's maximum return would be okay, yeah, just the maximum return is the absolute maximum. That may or may not be a relative maximum, but it's the absolute maximum. Does that make sense?
I thought that's the highest amount of like profit you can get.
Yeah, and that's the absolute maximum, right?
Yeah, and then isn't the highest rate of return like when the slope is the greatest?
But I thought.
So that would be double derivative.
Oh, is it? Um,
Well, he marked me down on it, so I was kind of confused.
when $X,000 find, what did you find? Derek, what did you find?
I just found the maximum slope.
Yeah, it's not the maximum, it's the maximum value, right? Because return is just the amount of money you're getting back, right? And so, see, the Y value, R of X, revenue, right? And X is the $1,000 you're spending on advertising. Actually, wait, hold up. Yeah, so you just want the maximum return. So, just the maximum amount of money you're getting back, revenue, right?
Yeah.
Am I wrong?
Good.
Did you
No,
guys
I
do it
don't
wrong?
think-
Or am I saying something wrong? Did any of you guys get this question correct? B?
Wait, which one?
7B, the ones Derek sent about maximum return.
Yeah. Yeah, you just have to put in your, well, our period is different, so I think we had a different question, but I'm assuming you just take the live value of the critical number.
Yeah, the
That
highest.
would be
Yeah.
the highest.
Yeah.
Yeah.
Does that make
You have
sense?
to ask for maximum rate.
Yeah,
and everything.
Oh, I think I got it right. Yeah.
Was it just the maximum Y value?
Wait, what is the
Yeah.
question asking? Highest rate of return? Or?
The maximum return. Derek sent it in homework help. It's basically, it gives you a function representing the revenue in thousands of dollars for X. X is in thousands of dollars spent on advertising, and your Y is the revenue, and it's asking you for the maximum return. What X will give you the maximum return?
Oh,
So I'm pretty sure that's just the maximum Y value, right? Because return is basically if you sell how high you sold your product for, right? Which is your revenue. So it's just the maximum return. Does that make sense?
Yeah.
Okay. All right. Okay. There's not. Does anyone else have any other questions? I can go over more derivations as well. Oh, I see something.
So the slope in like economic terms would be like the rate in which one receives profit.
The rate. So like let's say I'm putting in more money into advertising, right? At let's say I put in like I'm just increasing, like I'm just like giving more money to the advertising department. At a certain point in time, how much more revenue am I going to get for putting more money? So like if I put in, so if I'm at $2,000, right, in advertising, and then I put in 100 more, how much more profit am I going to get from that? You know what I'm saying?
Yeah.
And then the double derivative is that rate increasing or decreasing? So if I put in another 100 after that, will that rate be higher or lower? Right? Which is,
Yeah.
if you think about it, that should tell me to keep going or to stop going, right? If I'm trying to be frugal and I'm trying to spend the least amount of money, get the most bang for my buck. But then maximum return is just the highest Y value. So for how many thousands of dollars do I put in, do I get the highest revenue? So that would just be the maximum. Does that make sense?
Maximum, wait, for maximum revenue, we just use the first derivative to find the absolute max, and then for maximum rate of return, we use the second derivative to find like.
Well, I would be careful in your wording because it just says the point of diminishing returns, so not the maximum rate of return, because you might have a higher one later on, but it's just at the point. So generally for these economic problems, there's only one point of inflection. So there's only one point of inflection that causes diminishing returns. So there's only one. If you look at my screen real quick, there's only one that goes from positive to negative, because if you had multiple, then it's hard to say which one it will give you which one is where the diminishing return starts. So the value of X at the point of diminishing returns, yeah, you take the double derivative and then find where this is. Not this. This is not what you want, but this. Does that make sense?
Oh yeah, because like I'm pretty sure our period has like the rate of return, the return question.
Okay, rate of return. Okay. Interesting. Maximum rate, that would be your highest dy dx. So it would be the same thing, actually. I guess they're the same thing. Yeah. Okay. Any more questions? I can do another one. But I'm not sure if you guys have all done your theory homework yet. I haven't, so. But I can do another one, maybe like, I don't know. What time would be useful to you guys before the theory final? Sunday, maybe? Or Saturday?
Like Saturday.
Okay, I'll do Saturday. Okay.
Do you have school Monday?
Actually, not sure.
Yeah.
Oh, we do. Oh, dang.
It's weird because the day after a break we usually have off.
Okay.
Wait, can you do 19?
Yeah, 19. Where is it? Which one? The one you just sent, or shoot, I can't even
Yeah.
tell anymore. Oh, you just sent it. Okay. 19. What's the question? It's like the thing above. It says interval as an inequality, but I'm not sure what the full thing is.
Write the interval as an inequality.
As an inequality, are we using x or?
Yeah.
Okay, well you would just say x is. Shoot, yeah, x is. Can you use infinity or not?
You can.
Okay, so I guess it would be that. Generally, this is what I put, and he's fine. That's the all real number symbol,
Okay.
or it's
So
this.
the answer says x is greater than or equal to 1, or x is less than or equal to 1. What are you going to add?
X is greater than or equal to 1. Are you sure that's number 19?
I can send the answer key.
Yeah, okay.
That one has 0, so it's like the answer.
Yeah.
Is this correct, or like did anyone else get this?
Yeah, that's what I got.
Cuz that's the only way I can
Yeah.
feel that's other than
I
this.
don't understand how to get like 1 out of it.
That just might be I feel like that just might be a typo, cuz that would the symbol for that in interval notation, that would be this, or not that. It would be this. So I don't know. That I feel like that's wrong. Or no, it wouldn't be that. Shoot, it would be this negative infinity to 1 and then union 1 to infinity. That's what that is. That's what the answer says, but that's not what we have. So I feel like that's just wrong. Okay. 19 on the one Derek sent. Okay.
Oh, just to clarify, a continuous function is a function that has like every x value, but like it doesn't like suddenly change.
Yeah, so you can say that it exists for the function exists for every x value, and then also the limit exists for every x value.
Oh, okay.
Both the value and the limit exist.
And then differentiable is when every x value has a
Every x value has a derivative, and then the limit of the derivative exists as well. Right? So it's the same.
Is it derivative of limit?
Yeah. So it is, so that the derivative. Oh, fair. Yeah. Yeah. I guess so. Yeah.
Wait, so in continuous you can't have like y equals absolute value of x, right? The sharp points.
Continuous y equals absolute value. Yeah, you can't. No. Continuous, yes, you can, because the limit exists. Right? Continuous. Absolute value x is continuous because the limit exists. Just in terms of straight y values, the limit exists. It's not differentiable because because the limit doesn't exist. Yeah, and also Derek, you're right. You could just say the derivative has to exist at every point.
And what about like ln, like absolute value of x? Would that be continuous?
ln absolute value. I think it's continuous for all values that aren't 0. Which sounds weird because it's like, yeah, so I would just say it's not continuous. If someone asks you if it's continuous, then it's not continuous.
Yeah, because it doesn't have an asymptote.
Yeah. And if something is not continuous, it can't be differentiable either, right? But if something is not differentiable, it still can be continuous.
Wait, say that again?
So if something is continuous, right, like absolute value, it's continuous, but it's not differentiable, right? But something that's differentiable also has to be continuous. Sorry, that probably was not a lot. That probably was not simpler, but does that make sense, or do you still?
Yeah,
Okay.
So wait, a continuous function doesn't have to be differentiable.
No.
A differentiable function has to be continuous.
Yeah.
Is that because like
you-
you can differentiate? Oh wait, my bad.
Wait,
So,
wait.
continuous-
Actually, Avi, finish your sentence first, cause I can explain that real quickly.
Is that because like you need like there can't be you can't differentiate like an open point?
Yeah, because if you look at the the limit definition, it's f of x plus h minus f of x, and so that needs to exist, right?
Oh, okay.
Over h. Yeah. Okay. What were you gonna say, Derek?
So a continuous function is basically just a function without any open points.
Without any open points, and then the limit exists, so there's no jumps.
Like the limit exists for every point.
Yeah. So there's no jumps like this. It doesn't go like this and then this, because here at this point over here the limit doesn't exist because it's different from both sides. Even
Wait, so
and the reason for that is, look, technically the point exists, but the limit doesn't exist, right?
oh yeah.
Okay. Anything else? All right. Okay. We can do one on. I'll make sure to at least leave room in my calendar to do one on Saturday. All right. I guess I was recording the whole time too, so if you want to, you can rewatch it. All right. See ya.